Hi guys, I'm Satya from Edureka. Welcome to the session of Android. If you can hear me and if you can see me, can you quickly acknowledge in the questions panel? Great. Yeah, I can see you guys in the questions panel. All right, I want you guys to experience and enjoy the session. I said experience because whatever you guys see on your cell phone, whatever happens on the cell phone, that is what exactly you guys are going to learn throughout the sessions. And this session is going to be fun because it's more of a workshop and more of practicals, and I'm quite sure that you all will enjoy this session. Guys, this session has been broadly classified into two sessions. The first one would be what is Android Studio, so that you guys will get an idea of what kind of IDE that you guys are going to use. And then we're going to conduct Android Stack. Now, deliberately, I'm going to go a little bit slow on this Android Stack because this encompasses the Linux kernel, device drivers, and about the NDK. Like you can even start coding in your C and C++ language. And then comes your various managers. And on top of it, the Android programmer will be there. So by the end of the Android stack, you guys can decide whether you want to be the driver programmer, do you want to be an NDK programmer, or do you want to write some service managers the way that you all are going to see under the managers, or you want to be the application programmer. So this in turn will create various verticals, and you can decide what is your passion and where you want to be. So I want you to give a little bit of prominence to this particular session, and I'm pretty much sure that you're going to like this Android stack. Down the line, it may take some time to digest. Even after this session, even in the next session, you guys can start shooting up the questions so that I'm going to clarify all your doubts on Android stack and the Android framework. After that, the most important thing that what you will be awaiting is to install your Android Studio, right? So we're going to talk about how to install the Android Studio. Now at that point, what I would recommend you all is to install the Java first and then the Android Studio, and I'm going to walk you through that. Then we're going to take a deep dive into Android programming, and whatever the program that we do, it'll encompass your Android framework. That is how religiously we all say hello world when you start learning something new, right? And that is what we're going to do. But for that, we have to have a kind of in-depth knowledge with your Android stack and with the Android framework. So after that, we're going to say, we're going to write a simple program with activity. After that, we're going to learn the activity lifecycle. Now, after you guys learn the activity lifecycle, that is where your first session ends. And in the second session, I'll be walking you through the various other contents. Now, what exactly is the Android Studio? And in fact, this in turn is going to give you all the IDE, and this is more or less like your Eclipse IDE. Initially, the Android started off with the Eclipse, and slowly the Google disowned the Eclipse. That's about 2 years ago, and they moved on to Android because Android Studio has got a lot of collective objects and components and Gradle and a lot of other stuff, unimaginable stuff in this Android Studio. And that is what we'll be using throughout the course. And anyway, I would suggest you guys not to use the Eclipse, and please do not wander from Studio to any other compilers like Eclipse, right? Now, it's all free. It can be downloaded from your net. I'm going to show you how to download. And here, Android Studio, Android itself is the open source, and it can be, in fact, if you want to, you can install the complete open source onto your system and you can compile it. You will get to see every bit of the code and nothing is hidden from you, and you can walk into every bit of the code, you can recompile and you can play around with that. And the entire stuff, not the entire stuff, about 75 to 80% has all been written in Java. Like for you at the UI, meaning you being just a beginner, just an Android programmer, you'll be using the Android Studio and you'll be writing the Java applications. And we have something called as the Gradle build in it. And the Gradle build is something, it is phenomenally huge and big. And throughout the course, I'll be explaining how to use it and how to bring in the library, how to bring in the flavors, how to bring in the ProGuard, and there are tons of stuff that what you guys have to learn from the Gradle build. All right. So having said this, let me give you an introduction to Android. Like what exactly is Android stack? Now let us go deeper into the stack and let us try to understand the Android architecture and let us try to understand how the architecture works. Once if you get a clear idea of how the architecture works and your application that whatever you guys are going to write will be mounted on top of the architecture, and that is how you'll start learning how to write your applications. So this architecture happens to be the most important part of your Android. So you have to be a bit focused on this architecture. All right, guys. So every 10 minutes, I'll be looking at the questions panel. If you have any questions, if you have any queries, please do leave a questions in the questions panel. All right. So I cannot see you guys because I have enlarged my screen and all of you are in the background. Just in case if you want me to mute you at any point of time, please do ask me to mute you. I'll mute you so that you can get your questions clarified. Right. So let us get into this Android stack. Now, this is how the stack looks like, and this is what you guys are out to learn. So normally, being a developer, you guys will be sitting here on top, that is at the application level, and this is the area that where you'll be writing all your codes, all your programs, right? Now, I'll be starting from the Linux, from the bottom layer, and then I'll be taking you all the way up to the applications. So let me tell you what kind of an animal is Android and what exactly is Android, right? So let me talk to you right from the Linux kernel. Now, as I told you, Android is an open source platform for the mobile development. Now, Android is they have scooped all from the Linux and they have created your Android on top of Linux. Now, it consists the complete stack of the Linux hardware as well as middleware. Now, this is what we call it as a middleware, wherein after the Linux kernel, we're going to see the hardware abstraction layer here and then the libraries and then the framework. All this comes into the middleware and then it goes all the way up to the application level. All right. Now, Android, so it's based on Linux 2.6 kernel. Now, they're using this kernel to create the complete Android system. Now, let me say if a company, let me take a healthcare company, they want to use the cell phone. They don't want to use the cell phone the way it is. No, they want to convert the phone to the healthcare system. Like for example, it has to become the doctor-friendly phone. They should be able to see the heart rate. They should be able to see the ECGs. They should be able to get a lot of other informations from the healthcare systems. So the most of the people in healthcare, what do? They in turn, they recompile the Linux kernel. They will try to scoop whichever the components they want from the Linux kernel. They'll put it into the device and they recompile this particular Linux kernel into their devices. So that is how you can bring in a lot of additional characteristics into your device, or you can eliminate whatever the characteristics that you don't want in your device. Now, if you guys look into your device, it is not 100% of Linux that what you guys can see in your device. It is only a part of it. And the very minute I talk about Linux kernel, all of you would be excited about the process, about the schedulers, about a lot of other stuff. No, they have tweaked into everything. The process is truly not the process that what you see in the Linux kernel. When it comes to Android, as the application developer, the process that what you see, it'll have the flavor, it'll look more or less like a process, but a lot of stuff is being tweaked in by Android because they just wanted to take what they want. They don't want the entire overrides of the Linux. So they have tweaked into the Linux. So please do remember it is not 100% of Linux what has been used in Android. Now, this Linux in turn does quite a lot for us. And this in turn will take care of the memory management, process management, and networking management and all that. And this in turn will literally take care of your hardware as well as your device drivers. So when you have to deal with your camera, now the camera in turn will have a driver, and now you guys have to talk to the driver from the libraries or from the HAL layer. There is a hardware abstraction layer. Now for that, in this library, you guys would have created the .so file. Now the .so file is being created by the NDK, and that in turn can tweak the hardware, can take the information from the camera and give it all the way up to the application framework, and then the application framework in turn will give that information to your applications. So this is how you'll be retrieving the information from the hardware, and it is being given to this library via the NDK. In turn gives it back to the application framework, and then the application framework gives it back to the application. For example, now let me say that you want to zoom in or zoom out the camera. Now let me say you're in the application level. All that you do is you'll have an API to zoom in. Now when you zoom in, now you're trying to deal with the hardware. Now directly there's no way that you can deal with the Linux kernel. Now you have to talk to one of the managers. I'll come back to it and I'll talk about the managers when I come to this application framework. And you have to talk to one of the managers in application framework, and that manager in turn will be talking to the NDK. NDK in turn would have created the .so library. That in turn will be talking to the camera driver. So via the driver, you will be zooming into the camera, you'll be zooming out of the camera, or you will ask your camera to take a picture, and that is how you will talk to the hardware. And that is how you guys can come from all the way up from your application to the camera, and you can start taking your pictures, or you can start zooming in and you can do a lot of other activities. Now, apart from this, now here the Linux kernel in turn will help you to deal with all your inter-process communications at the high level, and this has the binders, and this Linux kernel has the job schedulers, and it has got a lot more to it. Now after this Linux kernel, now this is where practically you guys are going to see the device drivers, and this is where practically you guys will be talking to the hardware. Now let me go one level up from the Linux kernel. Now in fact we have a glue between the library and Linux kernel, and this is where you will get to see something called as the hardware abstraction layer. Now all the .so files that what you write in your libraries can sit in your hardware abstraction layer. That in turn will enable you guys to deal with the hardware directly. Now when you guys come to the library, as I told you, you will be interested where exactly the Java works and where exactly the C++ comes into the picture. Because many of you will be the staunch C++ developers. You still want to be on Android, but you'd love to write everything using C and C++. You still have an option, by you guys will fit into this particular area, into the mid-level area, and you guys can write all the programs. Now this green block that what you guys are seeing here, completely this block dwells with your C++. You guys can write completely the C and C++ part of the program, and this in turn will fuel your Android, and it gives in a lot of power to the Android, right? Now when it comes to the Surface Manager, now Surface Manager is responsible for drawing different layers on the screen and different layers and different windows. Now the Surface Manager in turn will take care of manipulating the pixels and bringing in the images, bringing in the videos, and it'll suit that video onto the relevant screen, onto the relevant frames. And more or less predominantly at a very high level, that is how your Surface Managers will work. Now when you come to this OpenGL, whenever you're trying to use the OpenGL, your device needs to have the chipset, that is a 3D chipset, and it needs to have the accelerations in it, and then you guys can start using the OpenGL. This can be used by your camera and by your video recorders, and all that in turn will be using your OpenGL, right? So if you guys know about OpenGL, NVIDIA is using quite a lot of OpenGL, and they do a lot of animation kind of programs they write. And in fact, if you all have heard about the Life of Pi, and NVIDIA guys, they're a part of Life of Pi, and that is how they brought in that amazing graphics, and all the other stuff has been brought into it. Very similarly, this OpenGL will help us to bring in the 3D graphics onto the smartphones and onto the other devices, like your tab and whichever the devices that you hold. Now SGL happens to be, this in turn will help you for the two-dimensional graphics. All that is being dealt with is SGL. And when we come to this media framework, now this is where you will use your media players. You'll be playing the audio, you'll be playing the video and all that. And this is where you all will get to see all the codecs sitting here in this particular place in the media framework. Now, such as your H.264, your AAC, MP3, and MPEG-4, all those things will be here in this particular area. And those are the codecs what you guys will be using to play your video and to pause, stop, whatever that you want to do, you'll be using this particular codecs. So similarly, we have a lot of other stuff like your SQLite. Now, when you talk about SQLite, and guys, you would have been quite familiar with this, and this predominantly, this in turn will help you at the core to write your databases, right? Like creating database, storing, retrieving, all that is going to happen right from this place. And the WebKit will take care of your browsers. And now if you look into this Apple phones, the Safari in turn is using the WebKit, and the Google in turn is using the WebKit. All these guys, they use the WebKit to get best out of the browsers. So like this, we have various libraries, and these libraries are parallelly, it is related with the Linux kernel. So apart from this, you have the application framework. Now, before I get to the application framework, we have something called as the runtime library. Now, the runtime is very important. In Android, we use the Dalvik virtual machine. Now, the Dalvik virtual machine helps the smaller devices like your cell phone and all that. And this Dalvik virtual machine can make the program run in the limited environment with the limited memory, with the limited CPU capabilities, and with a limited battery. All right. Now, this in turn is called as DVM. The Dalvik virtual machine is called as DVM. And all the codes that what you write here, it'll be in form of a bytecode, and that in turn will sit in form of a file or in form of a jar file, and eventually you will get to see all the files as the DEX files. Now, normally the DEX files are used to run the application, the process in the smaller devices, and it is going to work very efficiently, and that is what your Dalvik virtual machine is doing. On top of it, Android has got something called as an ART on top of your Android runtime. That happens to be the Android runtime. And that happens to be a very interesting addition plugin that what Android has gotten. Now, when you compile your program, it doesn't really compile the program all over again. Whatever the lines that you have written, it just picks up those lines and it compiles that lines. So second time when you're trying to compile your program is going to work much faster, and that is where your ART will come into the picture. That also can be called as your just-in-time compiler. So when it comes to the core library, this got all the collection classes here, and that's about your Android runtime. And going back to this application framework, and this plays a very vital role, and this plays a very important role for our application development. Now, whenever you write an application, your applications, now you may write hello world, or you may write an application to make a call or to receive some data from the browser, or whatever the kind of applications you write. Now, under this application framework, what you see here is not predominantly, they're called as the managers, called as the activity manager, packet manager, window manager, telephony manager, content provider managers, resource managers, and so on and so forth. All these managers will be watching you, and in turn they will be providing the informations to you right from the hardware level, and whatever you ask for, all the information is being carried out to the hardware, and from the hardware they'll be bringing up all the informations for you. And this is how this application framework is going to help you to write your applications. Now, for example, if you write your activity, normally in Android, the applications that what we write is called as an activity. Now, immediately the activity manager will swing into action, and he takes the complete control. And activity manager is the one, he manages the life cycle of the application. Now guys, give me few minutes. I'm going to take you deep into this life cycle of these applications, and he's the one who's going to manage the life cycle of application. Now, when you start clicking on various applications on your mobile, now Activity Manager is the one who's going to hold the backstack, and back and forth he will allow you to navigate the applications, and he's going to give you a smoother experience, and this is what more or less the Activity Manager will do. Now, Package Manager is an integral part of your Android. Now this guy in turn will keep track of how many applications are there in your emulator, how many applications are running in your emulator, what kind of permissions has been given to that applications. All that has been taken care of by the package manager. Package manager happens to be a kind of brain to your application. Now all the application identity and the resources, or the resources meaning the application details, like whether it has got the right permissions, where is it been executing, is it being held, or what exactly is happening on your activity. All that information is being held by the package manager. So as you have the telephony manager, now for an instance, you're watching a couple of pictures from the gallery. All of a sudden, a phone lands, the call lands in. Now, how exactly that can happen? Because the telephony manager has to get the call right from the Linux kernel, right? Now, this in turn will be checking on the IRs, and this in turn will be checking on whether I received a call or not. The very minute the call is received, and the hardware abstraction layer will pick the call via the libraries, and then it tells the telephony manager that there's a call for you, and this telephony manager gives the call to the application, and that is how you guys will be able to pick the call right from the hardware level, right? And you call, you talk, and when you terminate, the telephony manager knows that you're terminated, and it goes tells the kernel back that the call is terminated. Now, very similarly, you have content providers. Now, I'm giving you an overview on a couple of managers because you've got a lot more managers than what you see on the screen, and we will be working while writing programs. I'm going to take you deeper into it. Now, we have the content providers. Now, the content providers are a very interesting stuff. Now, for example, if you're writing your application in SQLite, now whatever the application you write lives in a sandbox. It cannot be seen or it cannot be shared by the other applications. At that point of time, the content provider in turn is going to create a wrapper on top of your SQLite, on top of your application sandbox, and the content provider makes the data available to the other process across the sandbox. And there is a whole idea of using the content provider, and this is how normally we use the content providers, right? For example, the contacts. Now the contacts that what you have in your phone can be used by the other applications. That is a content provider. For example, your SMS. SMS lands into your cell phone, and the other applications may want to read all the SMS and display it in the application. Again, it uses the content providers. So like that, we use the content providers. Then we have the location manager. Now this is a very interesting stuff. Now we write everything related to the Google Maps. Now Google Maps completely rely on your location manager, and this location manager is a very interesting guy. And now, for example, you want to write an application wherein you're driving. Now at that point of time, you want to be told where exactly is that I'm driving as of now. Now, if you register with the location manager will notify your application that this is the X, Y coordinate that where you're driving. Now again, you can ask the location manager, hey, can you tell me the nearest places around you now as of now that where I'm driving? Then it pulls in all the nearby places and it tells your application that you're passing by a pub, you're passing by a hotel, you're passing by a hospital, and so on and so forth. Now you guys can even write an application wherein if you're interested in having a lunch in a particular restaurant, and when you're passing by at that time, the location manager will quickly post a message to you saying that you're passing by this restaurant, this is your favorite food, you want to stop by. And that is how interesting you guys can make your applications to be by using these managers. Now we have notification manager. Now this notification manager plays a very important role. Now it is not that already you guys would have seen, like if you have a missed call on your cell phone and when you wake up, you go to the notification area, and when you see, you'll know that you have a missed call, you have a missed SMS and all that. Now it is not only used for your SMS and for the calls. Now the notification manager can also be related to the hardware. Now it can be healthcare hardware or it can be any of the other hardwares. That in turn can start pumping the information to the notification manager, and the notification manager in turn will start giving it up onto the screen. It tells you that these are the messages that what you have received from the various devices, right? So This is how you get a lot of information from the hardware devices. Now, guys, I told you, now to your phone, you can attach a lot of other gadgets also. For example, in fact, I was consulting a company. There we wrote an application for a smoke analyzer. And that was a different board altogether. Now that board cannot go into the cell phone. Now what they did, they created a separate board and they added that board via the USB drive into the phone, and it can be used via the Bluetooth also. Now when you take the breath alcohol analysis from the driving guy, and this board in turn will analyze the alcohol level, the breath alcohol level, and then immediately it notifies, and the data will come to the notification saying that, what kind of alcohol that he has consumed. And from there, the data will go to the server, data will go to the cloud, and a lot of things will happen. So the notification manager can listen to the phone as well as into the various hardwares what has been plugged into the phone, right? Similarly, you have the view. The view happens to be a very interesting part of your Android programming, and this in turn will give you the core view to the application guys. And using this, you can start creating your own widgets, your own events, and you can do a lot of interesting stuff using the view. And anyway, we're going to see this later. Now, to give you a brief idea of what exactly is happening in the Android stack, and this is what normally happens in Android stack. And as of now, you guys are sitting here at the application level and you're writing your applications. Now, let me take you a little more deeper. Let me give you a kind of experience with this particular stack. Now, imagine you guys are holding the phone on your hand. Now, the My app, that what you're trying to see here happens to be your phone. Now, what is that I'm trying to do in this diagram is, I'm trying to bring in this Android stack. Now, you saw the various layers of Android stack here. This is the formal way of looking at Android stack, but I want you to understand how exactly the stack works on your phone. When you're holding your phone, how exactly the stack is related and how exactly the stack works on your phone. And that is what we are getting into as of now. Now, when you hold the phone on to your hand, imagine as of now, you're looking into some pictures. Now you're looking into the gallery. Now, when you scroll down, when you see down, you have something called as activity stack. In this activity stack, it holds the running applications. Now in phone, you all will see many of the applications it is getting executed, meaning it is running on your phone, and out of which it can be the gallery, it can be the phone, it can be calendar, browser, and lot more applications will be running on your phone. Now, as of now, you are watching some pictures. Now, whatever the application is running on your phone, that is what stays on top of the activity. Now in the activity stack, you all can see the gallery is on top of the activity stack. That means your application gallery is running on your phone as of now. Now let us assume when you're watching some picture, a call comes in. That is the beauty of phone, right? That's a priority that what happens on your phone. When a call comes in, it so happens that the call cannot magically, it cannot land onto your phone. Now, we have the managers to the right. Out of this managers, you all can see window manager, broadcast manager, location manager, and telephony manager. Now, as I told you in the previous slide, this is the middle level, and this guy in turn will be talking to the NDK and via the hardware abstraction layer, and he talks to the Linux kernel, and he receives the call, he gets a call, and he gives it to you. What exactly happens here? Now you have been watching the pictures, right? You are on gallery. Now the call came in. Now the gallery is being pushed below the stack, meaning it will go just down the browser, because I don't have so much of space to accommodate all the applications. Imagine this gallery is being completely pushed down below the stack under the browser. Now the phone is what is the active application now. Now the phone as such is going to come to the top of the stack. In the place of gallery, the phone is going to sit and you're going to pick the call. And when you're done with the call, you're going to tell the manager again. The manager knows that you're done with the call, and the manager in turn will, you disconnect, the manager in turn will go tell the hardware that you're done with the call. The very minute that you're done with the call, now the phone in turn is done, and the gallery, what was there in the bottom of the stack, is being brought back to the position, to the first place, like the way that you're watching the pictures, and the phone is being pushed down the stack. Now, whatever in your Android, whatever stays on top of the stack, only that application is alive. Only that application is running. The other applications are not alive, and it is all there in the stack. And we're going to go and we're going to take a detailed look at it later. Now, this is what I want you guys to understand. Now, whenever you click on some application, like let me say that you guys are going to click on calendar. Now the calendar is going to come to the top of the stack and the calendar will be working. And you click on some other application that is going to come to the top of the stack and that will be working. And this is how when you click on the applications, and this is how it is going to come to the top of the activity stack. Now here guys, I want you to get familiarized with when you start writing your application, what components is surrounded by the application. That is very important for us to know. Now we have something called as the manifest.xml. In manifest.xml, we have the launcher, we have the default, we have the action, we have category, and we have the data. Now here, this in turn will live in form of an intent filter. All this, the launcher, the default launcher means your main activity, and the action is the name of the activity. The category is whether it is the launcher or the default or whatever is being stored. And the data in turn will have the schema of the activity. Don't worry about it. I'll be going deeper into it when we start writing the programs. All that is being stored in the manifest. Now, for example, like you have so many applications like gallery, phone, calendar, browser, so on and so forth. Every application has its own manifest, and every manifest has a launcher. It has the action, it has the category, and it has the data in it. Every application has this, and this will be updated by all the applications. Now, all this information is held by the package manager. Now, guys, you know the package manager also comes under the manager, and the package manager knows that how many applications are living inside your phone, and how many applications are there, and which application is running actually, and which application is in control. All that information and permissions and all the other information is being held by the package manager, right? So that's how the manifest is ingrained into the package manager. So all the applications manifest is being stored in package manager. So the package manager literally knows how many applications are there in your devices. So apart from this, we have the view. This happens to be a different object by itself. Now, when you're writing an application, now we call activity as an application. Now you get to see the screen. Don't get excited just by looking at the screen. The screen that what you all see on your cell phone happens to be the view, right? Now, when I talk about my app, this is where the activity will come into the picture. Now, actually, when you see your application, you can imagine two layers. One is your application layer, and on top of it, the view is sitting there to show you the screen. Right, the view is going to act as an interface with your application. So that is how the view is imbibed on top of your applications. So the view in turn has a subclass called as the surfaces. Now, if you want to bring the picture onto the application, or if you want to bring a video onto the application to display, you need something called as the surface flanges, and that happens to be subclassed from the view, and that is how you're seeing it under the view. And while writing the media players and all that, and we're going to go to the surface flanges and we'll see what it does. Now, apart from that, you have something called as the use permissions. Now, this use permissions is used under the manifest. Now, for example, you're downloading software from your Play Store, and your phone does not have the camera in it, and you want to download a camera application, right? So you're going to goof up if you're able to download the camera application, and when the camera application shows up and you will start clicking on camera, but your phone does not have the camera, right? So in this situation, now in use permission, while writing the program, you would have mentioned that the hardware, whatever the kind of hardware that this device is going to use. Now, my cell phone is using the camera, my cell phone is using the network, Wi-Fi, all that is present. If you say so, now such a Google in turn, the Google Play Store in turn, will let you download the application which has a camera in it, the application which has a network in it, the application which has got the Wi-Fi in it. Just in case if you're not using these permissions when you're trying to download it from the Google Play Store, the Google Play Store first will go to the use permission area and checks this particular word for camera. If it is not there, the Google in turn will not let you download any application related to the camera. Now, this is how the use permissions will work. The use permissions will help you to download the applications from Google, and the use permissions will request for the permission to use the camera as well as the Wi-Fi and all that from various other managers, and you'll be using it in your equipment. Now, coming back to my app, guys, do remember your application by default is a threaded application. Now, don't come to the conclusion something may ring in your mind. You all may feel, oh, even Java also has a thread by default. Now, somehow you guys manage writing application not using much of thread in Java because we all tend to avoid threads in Java. But in Android, it is a must. And if you don't use thread, most of your applications will not work. All right, so thread is very important. So here they have gotten 30% of the Java thread. The rest is all the Android related threads. The Android thread has got the message queue. It has the handlers, it has the loopers and so on and so forth. Everything is there inside it, and that's something very exciting and interesting. We will be looking at it when we write the thread applications. So please try to understand, right on day one, the first Hello World program that what you're going to write, it will be running by a thread. Then the most important thing here is the logcat. Logcat is been very well named because the logcat is curious about everything. Now when you're running your application, the logcat is monitoring, watching your application. Every variable that what you're using in your application, the logcat knows. So using logcat, you can start watching your application on which state my application is in, which part of my application is running, why my application is sluggish, and all the other information that you can start getting it in the logcat. Now, the logcat is going to help you only in the debug mode. When you're in the debug mode, if you're running applications like gallery, phone, calendar, browser, all the applications will be there, but one applications will be running. Now, the phone will be running in the default. Now, probably the browser also is running in the default mode. At that point of time, the logcat can watch. It can start dumping the information of all the applications like gallery, phone, calendar, browser, and so on and so forth, so that many a times you can use logcat to know why your program is sluggish. Now, you will get to know why your program is sluggish is not because of your program, because somebody is holding the view for a ransom. Some bad application is sitting there making your program sluggish. All that you can figure it out using your logcat. In fact, while writing the program, I'm going to talk more about logcat. Now, after that, you have the file manager. This happens to be a very interesting part of your Android application. Now, this in turn happens to be an integral part of your Android, and no one can lay their hands into the file manager. Now, this happens to be the internal file system. Now, whenever you create an application, now let me say you're writing a gallery application. Now, this lives in a sandbox. Nobody can see, nobody can retrieve the data from the gallery. Nobody can use it when it is there in the sandbox. Now, this is where, guys, the content provider is coming, and it has made the data, whatever is available in gallery is global, so that all of you can use the data from the gallery. Now, such applications will sit inside the file manager so that it cannot be shown to the other users, or the other users cannot see what is happening inside the file manager. For example, it comes under the packet names of what you write. Then, for example, if you're writing your SQLite database, that database is going to be there in the file manager. And if you're writing anything related to the shared preferences, that is going to be under the file manager. All this data cannot be seen by the outsider, and this is going to be common to the process that what you're running, and those are the data that what sits inside the file manager. Then comes the emulator. This is something interesting. Now you guys would have been writing programs on Apple phone, and now for the heck of it, you want to write a program in Android. That doesn't mean that you have to buy a phone. The Android in turn is going to give you an emulator. You can run, I would say the emulator is going to act as 95% of your phone, and you guys can run your applications straight on the emulators, right? Now, for example, Android from version 5, the new phones will come up with version 6, version 7, and so on and so forth. Now, every 6 months, we cannot spend 30,000, 50,000 to buy the phones. Is that right? We cannot go on buying version 5 and 6 and 7 and so on and so forth. Now, in this situation, you can create an emulator from version 7, and you can write your program, and you can stimulate the entire thing in this particular emulator. So you need not have to buy the phone. You can run all the programs on the emulator, but emulator in turn cannot run most of the applications, like your location managers cannot run on the emulator. The call managers cannot run on the emulator, and the sensors cannot run on the emulator because it has to happen with the real DSPs. In turn is going to sense and get the information for you. All that will not work on the emulator. This works only on your regular devices. So a couple of stuff will not work on emulators. Be aware of that. And there are ways to stimulate it also that we'll see it later. Now, this in turn will give you a complete idea of what exactly is your application and what exactly is happening around you is what is that we have seen roughly till now. Now, most of you will be focusing on the UI, and you all will feel that if my UI looks good, my application is good, and you'll feel really happy about it. And you all will feel that you have written a fantastic application because your application looks good on the cell phone when it is executed on the phone. What next? When you're done with writing the application, that gets under the hammer that goes to your manager, and then the manager will scrutinize your application using your device monitor. Android has something called as your DDMS. That is what you call it as a device monitor. Now it puts your application under the hardness test, and it checks your application for the performance analysis, and it checks how much of the memory your application is hogging, and it checks the hierarchy view, and the trace view in turn will show you why your application is sluggish, which part of the application is running really slow, and how much of battery your application is consuming. The battery historian is at another place where you can see the activity of your battery when an application is running. All these things has been checked by your manager using your DDMS. Guys, you'll be learning how to write your DDMS and how to go through all these levels and how to check your application in the following sessions. And now your manager in turn will mark your applications and is going to send it back to you saying that correct on all this and come back to me. And unless your application runs through the hardness test, unless you get 100% right result, your application cannot go out of your build level. Like, it cannot be given to your clients. The manager in turn is going to stop it because the user is going to get a bad experience. When they get a bad experience, and they will not use your applications, and it's a bad name for your company. And this happens to be the most important thing in your development cycle. And this is what you guys will be learning down the line. Now guys, in fact, I've been talking about the application level. Now let me go back. I've been explaining about the application that what you're writing, and you saw the application framework to the right. You saw the managers who are sitting and helping you to do what you have to do. And the library in turn was tweaking into this kernel, and you was getting all the back and forth information. And this is what you guys have seen so far here. But we have not seen the hardware yet, and we have not seen these red blocks yet. Now, before I move on to the hardware, I'd like to know if you guys have any questions, and before I head on to the hardware and before we start the application, and I want you to get yourself clarified. So please do let me know if you have any questions in the questions panel, or please do let me know if you want me to unmute you guys. I'm going to unmute you and you all can talk to me and you can get the concepts right, and then we can move on to the next concept. Can I quickly see an acknowledgement from you? If this concept is clear, tell me yes. If the concept is not clear to you, if you have any doubts, say no, and or you guys can ask me to unmute you. All right, I can see a lot of you answering, so let me read this. Oh yeah, I can see a question from Neil. He's asking me, what is the difference between the ART and JIT? Now, the ART in other words is called as JIT. ART means it is the Android runtime, and JIT means it is just in time. Now, ART has been got into this Dalvik, that is a Dalvik virtual machine, as a kind of plugin, wherein you need not have to recompile the program all over again. Now, if you modify your program with about 3 or 4 lines, now you need not have to recompile all the 1,000 lines of your code all over again. Now, ART in turn will help you guys to compile only the 3 lines of code. That means, imagine you're going to take a couple of milliseconds to compile your program, and your program gets compiled, and just-in-time compiler is more relevant to the ART. that is just in time. Now, whatever has to be compiled, you compile only that and it executes your program. So when you're compiling your program for the second time, it is going to be, the speed will be amazing. It is going to be really quick and really fast. Normally, in the other applications, in your Visual C or in Java platform, on wherever you are, you have to recompile the complete code. But Google has come up with a fantastic idea. Why is that I have to recompile the complete code? I'll recompile only the lines of what you have changed. And that is where the ART comes into the picture. Is that clear, Neil, or do you have any other questions? Great. So guys, you can ask me to unmute, or if you want me to, I will unmute you guys, or even this questions panel is fine. And if you have the simpler questions, then we'll start clarifying it in this questions panel. Now, let me move from here to the hardware level. Now, let us see what is waiting for us in the hardware level. Now, as I told you, when a call comes in, magic cannot happen. It has to happen from the hardware. Now, the telephony in turn has to go talk to the hardware. All right. So I didn't have much of space on the screen, so that the hardware has been pushed on completely after this. Now, guys, you all can see this NDK. Now, the green box that what you saw, these libraries that what you're seeing here, there is a Surface Manager, OpenGL, SGL, SSL, FreeType, WebKit, SQLite, and all that. These libraries and the hardware abstraction layer. Now, this two layers is being taken up by your NDK. Now, NDK in turn is going to deal with the libraries. Now, you'd have predominantly you'll be hearing the .so files. Now, the .so files are the files that in turn can mediate with your hardware as well as to the upper layer, and that is what is being written using the native development kit, and that is what the NDK means to you. Now, the NDK means it is a native development kit. Using the native development kit, using your C++, you'll be writing your applications there. That in turn can tweak between the hardware, and that in turn can take the information all the way up to the user, on to the topmost layer, that is the application layer. Now, guys, do not ask me, wow, C++ is allowed in Android, so let me write C++. So will my application is going to be faster compared to Java? Because normally they say Java is about 17 times slower than your C++. Now, my application, will it be 17 times faster? Even that is considerable stuff that what I can do for my application. That is what you all may ask me, but my answer is no. Now, the speed will not increase just because you're writing it in C++. Now, NDK happens to be a different subject by itself. Now, when you get to NDK, you will get to know when to use your C++ and why it will be faster, why it will be slow, and how that in turn can talk to the hardware, and how that in turn can talk to the application layers, and all that you'll understand only in NDK. In this SDK, Android development, you guys will not be learning much about NDK, but as and when it is necessary, I'll be giving you a lot of ideas, a lot of thoughts, provoking thoughts, and I will tell you why NDK and why it comes into the picture and how it talks to the hardware, all that I'll be talking. But all this will happen only at the superficial layer. Now, the way that you guys saw in the libraries, just to remind you, the media have got in the framework, SQLite, OtherGL, and all that, and everything is pertaining to your libraries. Now comes the glue. The glue happens to be the HAL. This happens to be the hardware abstraction layer. Now, whatever the .so files you write, and that in turn is passed on to the glue, and this in turn will talk to the driver, and the driver in turn will talk to the hardware, and he gets the information, gives it back to the glue. From there, it goes back to NDK. From there, it goes back to the managers, and from the managers, it'll come to you. That is where you guys are sitting. Now, apart from that, there's something very interesting for you. When you're writing your Android applications, all of a sudden, for no reason, your application may quack, and your application may say that please rerun the server to bring your applications up. Now here, you have a very thin bridge between the hardware and the software layer, and that is what is this. Now, this I'm calling it as running server keeps the above framework at buoyance. Now, this in turn will be running a consistently, a server will be running on top of the hardware, and that in turn will keep the user. Now, whatever the diagram that you see, all that is at the buoyance of your server. And this is alive, this is intact, and this is working because the bridge is on. The very minute you burn the bridge, this application is going to collapse and everything is going to die. Your Android Studio will not compile, your Android Studio will not work, right? So that is when you have to rebuild, you have some ADB commands to rebuild the server, and we can restart the server so your application will be up and running. So this is the server, it is going to build a bridge between the hardware and the software, right? Now apart from that, we have the Linux kernel. Now when we talk about the Linux kernel, I have given you enough of information. Now this in turn has got limited amount of information. Now all the information that what it has in your Android device is not genuine, meaning it is not 100% of Linux. The entire thing has been tweaked and they're using what is required for your devices. And that is how they've scooped the Linux, they have recompiled the Linux on your devices, and that is how they've gotten the Linux on your devices. And this is all about the Linux kernel and hardware. And guys, you're seeing the runtime, ART and JIT, that is the just-in-time compiler and the core library, all that is sitting here as a part of it. And this is how the complete architecture looks like. Now, this can be called as the Android stack, or it can be called as the architecture. Now, when you're writing hello world, you cannot come to the conclusion that, oh, I am writing my main and I'll use something like a print statement to say hello world. That's not the way the Android works. Now, even to say hello world, now, so much is going to happen in the background, and this is how the Android is going to hold. This is how your Android is going to execute your application, right? Now, you have been closely monitored by your managers, closely monitored by the window manager, activity manager, package manager, and even the power manager. Power manager is the most important stuff. For example, you guys are writing a game. When you're writing a game, you don't want the game to be switched off after 30 seconds because that is what you guys would have set your phone to, right? Because after 30 seconds, you switch off the screen. Now, using the Power Manager, you can request the Power Manager, keep my application on all the time. Now, this Power Manager will never let your application sleep, so that now here under gallery, phone, calendar, browser, you imagine your gaming application here. This gaming application is a hard nut. He is sitting on all the time. After you complete the game, you would have slept off. Now at that point also, the Power Manager has kept the wake clock on, and this application is consuming all the battery in the background, and he becomes a culprit for your battery drainage. And that is how you can use the Power Manager. Power Manager in turn can keep track of how the battery is being used, and battery historian can keep track of who is hogging the battery and what is happening with the battery and things like that. Guys, let me tell you something. When you're writing Android programming, this is yet another assembly language, I would say, because you just can't write the applications like the Java program. No, you have to be so critically, you have to watch every line that you write for your time and space complexity. If you write a bad code, that in turn is going to create an impact on the memory. That in turn is going to create an impact on your processor. That in turn is going to create an impact on your battery. Now, one line of code, so much is going to happen. So guys, please do remember that you have to write a good code and you have to take care of your time and space complexities. All right, so I don't want to bore you with too much of theory. Now is the time for us to get into Android and say hello to the world. Let us take up a simple program and see how to write an application. Guys, you know what? I want you to keep this diagram, probably a printout of this diagram next to you for a couple of days and weeks. So whenever you're writing your applications, I want you to check on this. I want you to elaborate this printout. I want you to go to the developer's site and see what is happening. I want you to start marking on a lot more information on your Windows Manager, Package Manager, broadcast locations and all that. And I want you to explore this. And I want you to stick to it when you're writing your applications. So please do not think it is like Java. All right. Now let us take a quick plunge into our installation. Now first, you guys will be curious to know how exactly to install your Android Studio. Now in fact, I'm going to give you 2 steps to install Android Studio. Just in case, if you're not able to install it, if you have any problem, you can write to support@edureka.co. Those guys in turn will swing in for the action and they're going to help you how to install your studio. So you have got support from both ends. So that is the beauty of your Edureka. Now it's a mandate for you to install the JDK and then come to the Android Studio. All of you will be wondering, oh my God, why is that he is taking me to the JDK screen? No, this is a mandate. Now when you click on this JDK, now this is the screen that what you all can see. And if you're using your Mac, please click on, I'm right here on Mac OS, please click on this and download the JDK. Or if you're using your Windows 64 or 32, click on either of this and that in turn will help you to download your Windows, the JDK for Windows, right? Once if you're done with this, the next thing that what you have to do is you have to install the Android Studio. So the second slide that where you're heading to is going to be installation of Android Studio. Now, just by clicking here at developers.android.com, this in turn is going to take you on to the Developer Studio, developer.android.com, and there you're going to get this button, download Android Studio 2.3.2, and you click on that for the Android Studio to download. Now, the Android Studio, the shell will download in a couple of minutes, but installing the SDKs will take about a couple of hours for you. Don't get disheartened, and this may take about 3 hours for you to install all the SDKs. Now, let me take you into the Android Studio. Let me show you how the Android Studio looks like and what you have to do after installing the Android Studio. Let me move on to that. Now, I have my Android Studio. Intentionally, I have not loaded my Android Studio. I have to go all the way back to my Launchpad, and I'm going to click on the Android Studio so that all of you will get an idea of how long it takes for this Android Studio to load. Now, if you have, what I would recommend is minimum 12 GB RAM and about your Intel i5 or i7 processor, and 12 GB RAM should be good. 16 would be great, but what I'm using is Mac. I'm using 16 GB RAM with the SSD drive in it. Now, when you click on the Android, this is how your Android Studio is going to look like. Now, even before I take you on to the application development, and I want to show you how exactly to install the SDKs into your application. Now, you all can see, start a new Android Studio project. We'll come back to it within a minute. Now, you all can see, open an existing Android Studio, check out blah, 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 all these things. Now, please go to configure, because I'm assuming that you're running the Android Studio for the first time. Now, click on the SDK managers. Later on, I will show you when you're right inside the Android Studio, I will show you how to get to this SDK manager there also. Now, when you click on the SDK Studio, this is the screen you guys will get into. Now, if you really want to, please start installing from the Honeycomb. Honeycomb is slightly latest. You can install from your ice cream sandwich from 4.0 till the Nugget. All right. Now, click on the show package for details. So what you saw was an abstract, right? Now, if you want to know more about what exactly is there in Marshmallow, what exactly is there in Lollipop, what I'm supposed to install, now click on the show package details, and then you guys are going to see a lot of stuff. Now, wherever you can see the tick mark, now let me do one thing. I'm not using much of the Nugget as of now. Now, let me take you to Lollipop. Now, here, watch the Google APIs. Please install this. Install Android Platform 22 and source for the Android 22. Now, if you're writing applications for your TV, you can install it. Or if you're writing application for the where, you can install this. Then you please install your ARM and Intel here. And that's about it, and you're ready to go. And please install this also, all the ARMs and your Intel, right? And you're ready to go. Very similarly, you're going to see the same in all the other variations also. For a KitKat, you're going to see the same stuff, and you can install the whole lot of the stuff right there by clicking on the true, right? That is something very important for you. So apart from that, please move on to SDK tools. In SDK tools, please install this, your Intel 86 emulator. Now, when you're running emulator, the emulator works because of this emulator accelerator. That is Intel 86 emulator accelerator, what you see here. Please install this. Do not worry about the NDK because you'll not be writing the NDK programs. And then please install the Google Play services. Here you all can see this Google Play services, and anything related to Google, you install everything. Down the line, when we all write the Google application, Google Map and all that, and we need the Google Play services. And also install the Android SDK build tools, CMake and LLDB, Android Auto API Stimulator, documentations for Android SDK. Install all that. Wherever that you see the tick marks and whatever that I've installed, please go ahead and install all these things in your system, right? So this in turn will take 3 hours for you to install. Do not get disheartened. And once if you're installed, you're ready to go with your Android, right? This is very important for you guys. Now, guys, are you clear with this? Do you have any questions with the installation part? All right, so I presume that you're okay with this. Now, let me go on to Android. Let me click on Start a New Application. Now, I guess that all of you are waiting for this time, and you all are really excited to see how to write your first application. And it's really very interesting. Every step that what you're going to go through will be very interesting. Now here, we have to give the application name. Now, you can give any name that you want. Now, let me call this as my first app, right? And so here, you can give your company domain here, and this happens to be the package name. It can be anything that you want. As a habit, we all say com.edureka.training.myapp, right? So like this, you can give your own package name. It can be separated by the various dots. When you give your company domain, when you give this, and that is what it is being treated as down the line as the package name, and this goes in the reverse order. Now you all can see this my app, training, edureka.com, and my first app. My first app is application name that has been tagged at the end. And this happens to be the package name. And guys, you know, this is the namespace in Java, and this happens to be a unique package name so that it will not clash with your other applications. Down here, you all can see the folder that where exactly that you're creating your first application. It is there in your Edureka sessions 3 and in your my first app. Now I don't want this to be under session 3. Now let me just go to Edureka, that is onto the first session, right? So now let me click on Edureka and I'll say next. I'll say okay, and I'll say next, right? It's in Edureka now. Now you guys are curious to know why, when I have my Nugget, why is that I have to use my Jelly Bean? That would be the question what you have in your mind. Please note, by opting to Jelly Bean, it says by targeting API 17 and later, your app will run approximately on 87.4% of the devices, which is prevailing across the globe, right? Now, this is being suggested by the Google Play Store. Now, because I don't care about this, I want to go up all the way to my Nugget. Now from 4.3 Jelly Bean to 7.0, let me say. Now please note here, you all can see by targeting API 24 and later your app will run on less than 1% of the devices. That happens to be the latest device. Not many people even will be owning the devices. So what is that you're going to gain out of it? Like you don't want to make little money out of your product. Like you want the maximum people to use it. So just for the testing purpose, for the compiling purpose, and for your personal reasons, you can use this. But when you're releasing this into the Play Store, I would not suggest you to use the latest versions because you all know that it is running for less than 1%. Now let me come back to Lollipop. Now Lollipop says 40.5% because it is not latest, it is getting obsolete and a lot of people are moving towards the other phones, the other versions. And now the Marshmallow happens to be the running one. Currently, this is what people are using, but in fact, as of now, but still you all can see only 4.7% of the people are using your Marshmallow. So let us fall back to the old devil, that is your API 17 4.2. Now guys, if you are working on the concepts called as the job schedulers, and when you're working on services and so many other concepts, and they will highlight, they will recommend you to use the versions above 21. Below 21, it will not work. That is what they recommend. Keep an eye on those things. Then again, after this, Android is asking you whether will you be writing your application in phone or tablet. Now I said, yes, I'll be writing my application with my cell phone and tablet. Now, not with my Wear or TV or your glasses. So I'm not clicking on anything. I'm going up to the next. Now guys, this is where you all can see the template, and when you click on this, you're going to see an awesome application coming up in front of you. Though you have done nothing, now the framework of Google Maps is going to be working for you just by clicking on this. Now, we are not interested in any of this because we wanted to learn the application right from scratch. We want to experience it, right? So let me pick on empty activity. Let me say next. And now it says the activity name, that what you're choosing is going to be the main activity. The project name is the first step, and this is going to be the main activity. Let it be, because this is going to be the internal name that what we'll have it for ourselves. Externally, the people cannot see this. Now, once if you're creating an activity, now initially I told you the activity has been enamored by the view. On top of your application, what you see is the view. Under the view, what you see, what has been mounted is the activity. All right. So the most important thing for you to understand here is this is the activity, and the layout name activity underscore main in turn will be referring to the view. Okay, that is what you have to remember. Now I'll take you back to the PowerPoint and I will show you how this will look like. Now in this case, you're going to see a beautiful screen. The beautiful screen appears only because of the activity main. Now the core part of the job, the workhorse, is the main activity. This is where you'll be writing your code to take care of it, right? So we are almost done, and let me say finish. Now he's bringing up the Android Studio. This will take a while. Now it depends on your system and configuration. This may come up in a minute, or it may even take about 3 minutes for you guys to see the screen. So don't get disheartened. Now let me close. I don't want the tips now. And when you select on the tips, and he's going to give you a lot of tips to write your applications. All right, guys, you're right there with your Android Studio. And I promised you that I will show you where the SDK manager is right inside the studio. If you have forgotten, or at any point of time, if you want to install, you want to upgrade your SDK, please watch this down arrow here. And if you leave the cursor for a couple of seconds, it is going to show you the SDK manager, and click on that, and this will take you back to the screen where we came from, right? So you should be familiar with this stuff, right? So that from here, you can go back to this SDK screen, and that is what I told you earlier. Now it's time for me to introduce to the studio. And in fact, if I run this application is going to say hello to me. Now, I'm not interested in seeing my hello, but I want to understand what exactly this studio is all about and how the applications is organized in this particular studio. Now to the right, whatever you guys are seeing happens to be the place where you're going to write your source code. And to the left, whatever that you're seeing happens to be most of this happens to be the resource related stuff, right? Now this RES is where all the resource related information is present right there. And in Java, in myapp.training.edureka.com, my first app, you all can see this main activity. When I click on that, this is your activity. This is what you're seeing here. Now it is all open to the right. Now this is your first application. Now you're hardly seeing one onCreate function right inside this, and nothing much apart from your extends app compact activity. All right. Now the most important thing for you to understand here is like what exactly is the resource and what kind of contents are there in resource. Let me give you a bird's eye view on this. Now when I click on the layout, guys, this is what you all saw on the screen. You saw the main activity and you saw the activity main.xml. These two files that you saw while building the project, and you all can see it all over here again. Now when I click on this activity main, now this is how your emulator is going to bring your screen up. Now this is the display. It is not the emulator, you're just watching the view. And this is how it is going to bring up the view, and it says the hello world for you. Now when you click on the text, and this in turn shows you how exactly it says the hello world, and it talks about the layout, what kind of layout that you have in your application. This will be discussing about these layouts in detail in the next session, because almost half the session is going to go with the layout itself, and we are going to design the professional applications at that point. Now we have the relative layout as of now. Inside that we have the text view. In the text view we have set the hello world, And that is how you guys are able to see this hello world. Now, to give you a little more explanation to it, let me go back to the design. Imagine this is your phone. You're holding it in your palm. When you're holding your phone on your palm, you know what? Your skin is hugging to the phone. When the skin hugs to the phone and it is eating up this particular space also, right? This edges. Now, just in case, if you get a button to the edge, and if you have a button, the way you're holding the phone, the skin in turn will press the button may get activated. And that's the reason we would prefer to give this lead space on the phone, right? So can you see the space from on the screen between the starting area to the hello world? There is a little bit of space. There's some space on top, and very similarly, the space is going to run through all over the screen. Now, how do we do that? Now let me go back to the text. Now here, you all can see the layout is the relative layout. I'm going to talk about it later. Now, this line has been generated by Android, so don't worry about this. This two lines is generated by Android. Now, this XML, this line is generated. Now, this line also is generated by Android, so don't worry about this. Now, the other immediate stuff that what you guys are seeing here is the identity. Now, if at all, if you want to refer to the relative view, you can refer to it with an ID name called as the activity main. This I'll be teaching you in detail later. By using this ID, you can refer to the layout. Now, inside the layout, you have, now let me push this line down. You have two important things. That happens to be the layout height and the layout width and then the layout height. Now, when we talk about the layout width and height, now this is the width and this is the height. The white screen that what you guys are watching here, this is the height and this is the width what we are talking about. Now, here we say match the parent. That means take up the complete space. How much ever is the size of your phone, let the width be of the same space. How much ever is the size of the phone, by height, take up the complete height is what you can say. Or you have an option to design, to choose how much of the screen that you want to use as the width. Now let me say 200 dp stands for the density independent pixels. I'll be explaining this to you soon. Now let me go back to the design. Now you all can see when I am here in this hello world, the screen, now the blue screen represents how much of the screen that you're gobbling up. That is the 200 dp. That means on this white screen, you're going to use this space as the 200 dp. That is all the screen you requested for as the width for some reason. Now, when you say match parent, it uses up the entire thing. Now, just for an example, if I say 350, now I'll go to design. Now, this is almost, it is even going beyond the screen, right? So can you see the bar? And this is ridiculous. So you can even say 500, that is meaningless. So better stick to the size of the screen. All right. So no, it is not 350. It is 3,500 I have given, right? That's a meaningless stuff, and 350 should be reasonable, yeah? You have almost come to the end of the screen, a little bit of space has been left, and 3,500 overshooted the screen, right? So you guys understood what exactly I meant by this. Now, you know what, I press control space, and no, let me delete this and press control space. Why it says no suggestion. Now, this guy in turn has to automatically bring up the match parent. Sometimes it happens in the emulator when it is buggy sometimes, so it happens. So I just got the match parents to be back. Now, all you learned is how to use the complete screen. Now, I was talking about the lead space now. I'm coming to it. Now, this is where you guys are going to use it. Now, you all can see the padding bottom, left, right, top, 16 dp. Now, that is the padding that what we are talking about. The padding to the left is 16 dp, padding to the top is 16 dp, right? Now, that is what is that we are trying to allocate in our application. Now, this is what it is. Now, when I click on this or when I hover the cursor on top of this line, it shows you something else. It is not 16 dp, it says at dimension activity underscore vertical underscore margin. Now, when I click on this, now you're not able to see the 16 dp. The 16 dp is conjured up in a file called as the activity vertical margin, right? So it is there in the folder called as a dimension. Now let us quickly go to the resource. Let me click on the values, and you already see the dimensions right there. Let me click on the dimensions, and let me click on one of, no, obviously you guys may ask me, what is this supposed to be? You have two dimensions here. Do not worry about it, and I'll be talking about it later. Now let me click on the first dimension, and here you all can see the activity horizontal margin is 16 dp and the vertical margin is 16 dp. Now if you want me to change, I can change this to 36 dp as the horizontal margin and 36 dp to the vertical margin. Now always keep the data in the data area. This is the data area. So don't try to bring the data. Don't try to hard code the data in your XML files. And that's how it says add dimension. That means it is going to the folder dimensions. Inside that you have the dimension XML. Inside that you have activity vertical margin, and you changed it completely now. Now when I come here, it will not be 16 dp. Now I'll just show you on the screen. You all can see it being pushed a little more inside because the 16 I made it to 36, and that is how you all can see the screen. So it has been pushed slightly inward. All right. Now I have to go back to these dimensions, and if I have to get this back, I have to change this to my 16 dp. So this is how you guys can change your dimensions, and this is one way of looking at it. Now you guys have learned what exactly it is, and then the tool context. You need not have to worry about it. Even without this, your application will work. And as of now, he's just giving the package name right there. You know what? I can even delete this and it'll not create any problem. My application will work. Now let me bring this back. Let that be there. Now this is how the relative layout is created. Now the relative layout is asking for the full screen, and you're giving the padding of 16 dp around yourself. Now you want to bring in a hello world. Now let us recreate this guy. Now you want to create a hello world there. So I want to bring in a text view widget. I'll type in the left diamond bracket and I'll type T. You all can see this text view, and I'll select that. Now this is asking me how much of width that you have got in your hand, and I'll say wrap content. What is the meaning of wrap content? If I have to say hello world, how much ever hello world takes, that is the width I want to use. And what do you mean by the layout height now? I'll again say wrap content. Now let it take the height of the letters as the height of my characters is what is that you're trying to say here. Now next, what you want to do is I just want to say hello world. So for that I'll type text. I just type T, and please come down and click on the text, and you all can say what you want to say here. Now I want to say welcome to Android, to the world of Android. This is what I want to say. Now the very minute I finish typing welcome to the world of Android, this yellow bulb, he is giving me a gentle reminder, hey, something is not looking good, can I help you, is what this guy is asking me. Let us click and see what he is asking for. Now he says extract string resources. Let me show you once again. Now here when I click on this, it'll bring this bulb and it is extract string resources. Let me click on this. And he is suggesting me that now the resource value. Now value is welcome to the world of Android. On top, you're able to see the resource name. Now this is what will be treated as a key. This is what will be treated as a value. And he's showing it up to you. And he says that, can I put this to for you in the strings file is what he's trying to ask you. And you're happy about it because somebody is there to do all the work for you, heavy work for you. And you just say, okay. The very minute you say okay, you all can see at string, you can see the variable is as good as your data variable. Welcome to the world of Android. You all can see this underscore right there, and it has been placed in string. Let us go check right there in string, and you all can see this line is generated for you. Now, if you want to manually, if you want to generate, it's pretty easy. You just type string. Now I just type a string. I opt for string, and in the name, I'll say hello. Instead of hello, what can I say? Let me say, hello Edureka. Hello. Hello Edureka. Now this is my key. Now I just want to have a value here. I'll close this. The very minute I close this and he completes it with a string, and this is where you can have the value. I'll say hello Edureka. Right? This is the value that what I can bring in. So this is how physically you can bring in the strings into this particular area. So please keep all the resources under the resources folder. And even if you try to write something right there, it will not create any harm for you. Nobody is going to kill you, and it's still the application will work. But down the line, you guys are going to be into trouble. Now all of you will be wondering what kind of trouble is that. Now, if you write your application like this is my word, right? Now I can understand this and you can understand this. When this application is compiled and it is being sold in Japan, they won't understand what you're trying to say. Or in Italy, they won't understand what you're trying to say. So they would prefer to have this in the Japanese language, or they would prefer to have this in Dutch or in French. Now to do so, do have all the declarations declared inside the string. If you try to declare anything of this sort, this becomes a hard nut for you, and these words cannot be changed, and this is going to remain in English forever. So when we get to the chapter of locales, I'm going to talk more about this, and there I'll be explaining how to convert this into Japanese or Chinese or into Hindi or into any other language. Now here we created one more string, right? So press Control space. Now you all can see hello app name, hello Edureka, welcome to the world of Android. Now I want to choose hello Edureka, right? So that guy came in here. When I go click on my design, and you all can see this is hello Edureka right there. If you want to change, if you want to change the text size, you can just type text size. Now guys, please do remember, I use the density independent pixels. I told you that I'll be explaining it shortly to you. Now for the text, do not use the density independent pixels. No, I just want my text to be of 30 SP in size. For whenever you're using it for the text, please use the SP, because this in turn will take care of your internal lead, external lead, and the width of the character. All the scenarios will be taken care of it here. Now let me briefly talk about this DP. Now when you are using DP, your application will be mounted on your tab or onto the small devices like 3-inch phone or 7-inch phone or 5-inch phone and all that. Now every phone, the pixels are different. Now if you're using 10 pixels, the 10 pixels may mean different in 3-inch phone, 10 pixels is different in your 7-inch phone and in your tab. But if I'm using it as 10 dp, 10 dp is going to look alike in all devices that what you're trying to use, and that's the reason it has been treated as the density independent pixels. Anyway, we're going to go deeper into it in the later session. I just don't want to leave you at this point, so I just gave a brief explanation to this. So when you're using the text, please use the SP, do not use the DP. All right, so let me show you how it looks like. Wow, this looks slightly bigger. Now let me color it up. It's fairly simple. Just type text and you all can see the color. And in the color, you have so many colors, and you can pick any of the color that you want, right? So you all can see the color at the right panel here, and you can click on the design and you all can see this color, right? Now you can create your own colors also, but do not do that. I'll tell you why later. Now this is how you guys have used the texture, and I think we have come a long way. Now let me also do one thing. Let me also teach you how to create a simple edit control and a button, and let us compile the program. Now before that, I will show you how to create a simple edit text. Now there are two ways. One is you can drag and drop. Now let me do one thing. Because it is a relative layout, let me convert this to the linear layout. Now by converting this to the linear layout, we are requesting all the widgets to fall one below other. All right, so that is what I want. Now let me do one thing. Let me bring in a button now. Now I'll just type this and I'll type B. Now the button is right there. Now the width. You know what? The width, I'll say match parent. Take all the screen of the parent. Height, let it be the wrap content. And here, the name of the button, text. So here I will say, let me push this guy down. Right, so here you click on this text, and here you can give the name of the button. So while giving the name of the button, you can say push me. This is the name of the button. And again, this guy is coming in and he says, hey, do you want me to help? And I'll say button push me. I can even change if I want to. And that's what it is, right? So you have the button right there. Now we have, let me go to the design, and I picked up the linear layout to, I told you that I wanted the button to be one below the each other, right? Under Hello Edureka, I just wanted the button to be below the Edureka. That's all I wanted. But no, it is not happening so. Now let us go back and see why. Now, normally the linear layout, the default characteristics of linear layout is we have to use something called as the orientation. When I type OR, the orientation comes in. Now please check on the vertical. By default, it happens to be the horizontal orientation. When you don't give anything, it is horizontal. Now you're picking up on vertical. Now we are done with this. Now I'll go back to my design and you all can see Edureka and Pushme is just below the Edureka, right? So it is all one below each other, you all can see. All right, guys, so it's time for us to compile this program and see how it works. Now let me click on this play button. Now, before I compile the program, I'd like to ask you, do you have any questions in creation of the file and about the resources? And like we have just seen how to create your resources, we have not yet walked into the main activity. Now, first, if you have any questions, let me clarify on the resources and then I'll move on to the main activity and for the compilation. So guys, do you have any questions here so far? Okay. Swati Chand is asking me a question that is, what is the role of SDK and what are the tools placed inside it? Swati, you know what? I would prefer to answer these questions later because we'll be getting distracted from the flow. We are in the flow of creating a small application and making it to work. And let us talk about the SDKs and let us talk about the APIs at the later state, right? Please do remind me later or by end of the session, I'll talk about the SDKs, or if you can wait for the other session, nothing like it. And if you're still curious by end of the session, I'm going to answer your question. So I'm pushing your question to the end of the session because I don't want to break the continuity here. Okay. So yeah, the rest of you are clear with this. Now let me go back. Now you guys have learned how to create your application. Now when you're writing a simple application, that is all these things came automatically to you. You had a main activity and you're extending app compact activity. Now guys, now you're extending your activity. Activity happens to be a part of your Android. Now, like Swati, the way you're asking me, the kind of APIs is present inside the SDK. Now, if you come here into this main activity, you're extending the app compact activity, right? You're under the hood of the activity. And if you want to know what kind of APIs are available for me, please press Control O. By pressing Control O, and you're going to see tons of functions what is existing under your activity, and these are the APIs, and you have API coming under the relevant banner. For example, if I take my locations, you'll have relevant APIs under locations. If I take the content providers, you'll have relevant functions under the content providers. So like that, it is very well organized, and I'm going to talk to you about it in detail later, just to give you the gist of it, because I don't want to keep you thinking, so I just took you to this particular point. All right. So Swati, I hope that you're just getting the insight of the APIs, like what you've been asking for. Now, this onCreate function, that what has been created, this is more or less like a constructor for your application, right, for the main application. So this comes in by itself. Now, then after that, I'll be talking about the bundle very soon. Just give me a few minutes. Then you're going to the super and you're trying to give all the saved instances to the parent, that is app compact activity. As of now, don't bother about this. This is more or less like your Java scenario. Now, then you're calling something called as the content view. Now, guys, I told you very clearly that you have two different layers when you're writing the application, and this main activity happens to be the core. Now, let me write a comment. We take care of core business logic. Now, when you're practically looking at this line, this is related to view. Okay. Now, what I want to say here is following line brings in view on top of the activity. Now, this is what exactly is going to happen. Now, the view is being brought on top of the activity. Now, if I take this line out, the activity does not even know about the view. This is what it means. Now, activity is an independent application by itself. Now, to do that, anyway, you saw the set content view function. Now, it is all there. When I retype it, it is all there. And it says integer layout resource ID. Now, let me click on this. Now you guys know that this is where you have got your text That is your Hello Edureka is sitting right here, isn't it? Now I want to get this and I want to print it in my main program. Now let me show you how to do that. Now after writing set content view, please type R for resource. Whenever I'm typing R, it gives me the package name, myapp.training.edureka.com. Now I'll say dot. When I say R dot, you're right here in resources. And when you say dot, you're going to get into the resources. Now what do you want inside the resources? You want drawable, you want layout, mipmap, value, and where do you want to go? I want to go to layout. Now guys, don't worry. I'll be talking about the mipmap drawables later. As of now, I'm omitting this. Now I want to get to this layout. Now here, I'll say R dot, I'll just type L. Now you all can see the layout. This package name confirms that you're in the right track. Now the layout is over and I'll say inside the layout, I'll press R dot layout dot. Now, whatever the files is existing inside your activity main, it is showing up everything. Now here, I just want to pick up activity main. That is a file that I want to pick. Now that is where you have the text view, and whatever is there in the text view, that is what gets printed onto the screen, right? Now, what we can expect here is Edureka here when the program is executed, and this is what you guys can expect. Now, how is that we can run this program? Now, we have a small catch here. Now, even before you run this program, we have to bring in the emulator onto the screen. Is that right? Now, let us see how to do that. Now, I'm just clicking on the play button. Now, it says it is initializing the ADB. Now, here already I have a couple of emulators sitting here, but I want to create my own. Now, let me say create new virtual device. Now, I came here to create my own emulator. Guys, you know what? You can create a TV as the emulator or the Wear or tab or the phone. Now I'm in my phone. Let me stick to my phone. Now, what kind of an emulator you want? Now here you have a very high density emulators, and it has got a big screen like 5.7 inch, or if you want the smaller screen, you have 5.4.0, and you have all the screen sizes, and you have the resolutions, and you have density. Now, when you buy the phone, you want to buy the best of the phone, right? So you always go in for the biggest screen and HDMI, HDPI, and things like that, because to bring up such devices, it may take a while, right? So let me moderately select, this is Nexus 6, right? Now, 480 also is too low, I don't want. Okay, let me select Nexus 6, all right? So I'll say next. Now, when you have picked the Nexus 6, now what kind of API is it that you want? Now here, which version that you want? Now here, you know pretty well that by selecting 7.11, 7.0, you know you get the very less number of hits. So you'd prefer to go in with the Lollipop 5.1, and this is what I'll say. Now in Marshmallow, it says it is there in your system, but you have to download this, download the SDKs. But anyway, I don't want to. Let me go to the Lollipop 22 and let me say next. All right. Now you have got the Nexus 6 22. Now here you can call this as my emulator or your company name, whatever the name that you want to give, it can be given here. So this emulator, what you're trying to create, and then like it is asking you that, hey, you have opted for this, do you want to change, or do you want to change the Lollipop to anything else, or do you want to change, by default it is portrait, do you want to change it to laptop, I mean the landscape, now let it be portrait, and then the emulated performance, all that is there. So don't bother about all these things and go on to the show advanced settings. Now this is interesting. You all may get excited by looking at this. Now it says the same stuff here. Now comes the interesting stuff. Now you'll get to see the RAM. Say, wow, I've got the RAM. I can control it. And do not jump into this and type the RAM size here, because every phone has its own limitations, and you have to know about the phone you're working on, the real device. The emulators are real devices for you, and it is going to pretend like a real device, and it is going to stimulate all the hardware what is present in that device. By changing it, if there is a conflict between the hardware and between you, emulator will not come up. So please do not touch all this unless you know what you're working upon, right? Now you have the various things you can try it out. You can play around this later. Now I'll go to my finish. Now this is the emulator you wanted. You have gotten my emulator, Nexus 6 and API is 22. Let me say okay. Now at this point of time, you're likely to get an error if you have not installed your emulator in your SDK, right? So be aware of that. So it's very important for you to install it, that I've shown you how to install it. Now this will take a while because this is almost like your cell phone and it takes all the time to come up because you're almost booting your phone. All right. So congratulations, you have written your first application and you all can see the hello Edureka and you all can see the push me button, but there is no relevance to it and you guys have not done anything with this push me button, right? So what is that you want to do with this push me button? Now, just by clicking on push me and let me print some text, right? Saying that somebody clicked on the button, right? So let's do that. Now here, it's a while that we moved out of the PowerPoint. Now let me go back to the PowerPoint. Now this is where we were and you learned how to install this and we moved on to activity and here you all can see it serves as an entry point to the user interaction. Each activity has a layout file where you can place your UI and application can have different activities. Now we have just created one activity. Now while writing your application you can have as many activities that you want. Now the activity that what we have created is a very crude one and to the right that what you're trying to see here is you have a Facebook picture and you see this email, a phone and password, login and a lot of other information over there in this activity. And just to show you the activity and we are trying to show you how the activity will look like. Right. Now getting back to the features of an activity, all activity interacts with the user in order to do something such as dial the phone, take a photo, email or view or map. Now guys, we have already written a program. We already have a button. Just by clicking on the button, I may dial a phone or I may ask my button to take a photograph or I may receive an email or send email. Whatever I want, I can do that. Now all this happens inside the activity. Now you all know that the view has enamored on top of the activity. As you all can see in this diagram to the left, you all can see the view. You all can see a calculator. Now obviously the calculator is a view. Beneath that you have an activity that in turn is going to do all the calculation jobs. Activities are presented as floating windows or embedded inside another activity. In fact, this floating windows, we'll talk about it later. In fact, that is called as the widgets. As of now, we are writing a simple activity and we are learning how to use a simple activity. But on top of the activity, you can bring in a widget or you can bring in as many activities that you want, right? Now, if you're using a calculator and if you go click on the gallery is going to surmount on your calculator and so on and so forth. You can bring in any number of activities on top. Now, an application consists of multiple activities that are loosely bound to each other. Now, when you have an activity, now you need not have to call this as the activity A, B, C, D. A is calling B, B is calling C, C is calling D. No, not necessary. Now, B in turn can call A, B in turn can call D, or B in turn can call C, C in turn can call B. So like this, the activity in turn can call each other however it is required. Now guys, please be aware, activity is not just your main activity or the screens, or it is not that like functions you're going to call the activity and we have got a lot more to it. Now, end of the session, you guys will understand how to create a component out of the Android. Android is just not an application. Android has got much better behaviors and beautiful stuff being ingrained into it, all those things that you're going to see, so that we are going to loosen up the tightly coupled applications and we're going to make all this activity as a components by itself. That is what you'll be learning as we progress. Now comes the activity lifecycle. Now briefly I have told you the meaning of activity lifecycle. That is, in the previous diagrams I told you, when you're with your calendar, when your phone call comes up, the calendar will go to the background and the call is there on top of the stack and you're going to take the call. That is what you all have seen. Is that right? Now, let me take you in the realistic way how the activity lifecycle will look like for you. Now, when you start your application, now the activity is started, all right? Then it calls the function called as onCreate. Now you guys have already seen that onCreate function in your applications and there is on create that you have called. That means the activity started and on create has come in. In on create we have displayed the text view, and in on create we have displayed the button. This is all that we did. What next? Now this in turn will call onStart, because the onCreate happens to be a kind of constructor function. Whenever the activity is created, only then the control will come to the onCreate. Now otherwise, whenever you recreate or when you reschedule your activity, or when your activity is called all over again, that in turn will call onStart. The control will never go to onCreate again. Always after that, the control will come to onStart when the activity is active. All right. Now I'm going to go deeper into the onStart, and I'm going to tell you how this onStart is going to help us down the line. Now we have something called as onResume. This also I'm going to explain in a minute from now. Then your activity is running. Now, hello Edureka program, that what you have written is going through this process. Activity launch, and it comes to onCreate, and we are not overriding onStart or onResume. And if at all, if you're overriding these functions, and it'll go through this onStart, onResume, and it will let your application work. And even without this onStart, onResume, your activity is going to run when I compile the program. Now, let us go back to the application. Let us compile and see how this application will work, and then we'll come back to this diagram. Now I'm back in my application. Now I've created the emulator, and now this activity is running, right? Now this is all that you guys have seen. Now you know what? I want to trace, did I really come into this onCreate? How do I know if I've really come into this onCreate? You all will tell me, yeah, you came in, because we all can see this hello Edureka there. You have come into this particular function. Now say your hello Edureka didn't print. So how do you know whether this particular function is being executed or not? Now for that, we have to bring in the log. We have the logcat, that what you guys have seen. Now that comes really handy here. Now you know what I'm going to do? I'm going to say log.d. Now this D stands for debug. I'll be explaining this to you. Now here to the log, we always give a tag, something like this, or it can be your name also. And here I can say a string, okay, on create, and this is where you landed, and this is how you can write a log function. Now it is throwing up an error, and it says that, now when I click on this, it says Android util.log. Please click on Alt and enter to get rid of that error. Now he brings in the relevant library, and he is out of the error. Now when you're using this log D, this is for debug. This tag in onCreate will be displayed to you in one particular color, because you said that I want to see it in the debug mode. Now guys, I just want you to experience this. Now the log in turn has got various elements to it. Now let me say log E. This means it's an error. All right. Now let me say log W. This means it is the warning. And let me say log information, for I for information, right? So like this, you have the logs, and you have got various parameters to it. Just by, let me remove this. Just by using so, all that it does is it changes the color and it displays it to you. Let me run this once again and show you how it works. Now you all can see the program is coming up. Now the hello Edureka is printed. Now you want to see the log, where exactly the log is present. Now guys, come down to Android monitor here at the bottom left corner of the screen, where I'm hovering my cursor. Click on the Android monitor. Now that's where you are. Now when you see this log, I told you this is not just displaying your application. This in turn can display all the running applications in your emulator. It can start showing all the applications data. Now, what do you want to do? You want to tell this log that, hey, I'm interested only in my application, don't show me the junk. So in that situation, you come to the top right corner at the bottom, you all can see that I'm clicking now show only selected applications, or Firebase no filters. When you click on no filters, all the applications will start throwing the log on this particular area. Now let me click on show only selected applications. Now you have to search in this junk for your messages. Now instead, if you can come here and type your tag, tag is what you give it here, right? That is your key. When you give the key right here, now if it is verbose, in verbose it brings everything. Now you know, oh, you have given debug, edit, warning, and I, right? So verbose is right for you. Now you all can see the messages right here. Now you all can see the debug is in black color, error is in kind of rustic red, and warning is in blue, and I, there is the info, is in black color. Now this is how you all can see the logs. All right. Now when we are talking about the activity lifecycle, let me bring in the properties into it. Now here we have the onCreate. Now next we went into on. Now I'm just typing on. I'll type capital S. You all can see this on start, right? This is what you guys saw, right? I'm going to click on this. Now I'm going to bring in on start. Now after that, what did you all see? On resume, isn't it? Now I'm just going to bring in on resume. And then you saw the application was running. Right after that, your activity was working. Now, if you want to check on the activity lifecycle, there are two ways to do it. One is you can go through the diagram of what I'm taking you through via Edureka, or the better way, like if you guys are very hungry for the data and you want to be really very professional, you all can go to developers.android.com. Now this is your Bible and this is where you get all the help, and here I can type in activity life cycle. When I type in activity life cycle here, and this is the ultimate place for you all, and this is where all the APIs and all the libraries arrived from, and this is where we take everything from, and this is the diagram that what you guys have seen in our PowerPoints also. Now we saw activity launched had on create, on start, on resume, and this is where the activity was running. In our diagram we came till here, right? I'm going to go back to my diagram. Then we need on pause, on stop, and on destroy. Let me bring this in and then I'll explain the meaning of on pause, stop, and destroy to you. Now let me go back. Now I want to bring in my on pause, right? Now I want to bring in my on stop. You know what, I can press Control O now. Now I will type in here on stop, S-T-O-P. You all can see this on stop here. This is yet another way of bringing it on stop, and then I can have something called as on destroy. Now I am going to bring it in the regular way. Now I've got all the events which is pertaining to my activity. Now let me put all these guys in a remark. Now I block the entire thing. I hold my control and a forward slash to put remark for all the 3 lines, right? So it goes into the remark. Now I'll just copy this and I'll put it everywhere, right? I'm just going to copy it here and on start and on resume, and I'm going to say, hey, this is where you guys are, right? So all that I have to do is start making my changes. Now here I'm in on start. Now here I'm in on resume, right? So here I'm in on pause. Here I'm in on stop. Here I'm in on destroy. This in turn consists of your activity lifecycle. Now, whenever you run your program, now let me rerun the program. Now I'm going to show you some magic happening here. Now let me see it all over again. Now, so far you saw only on create, right? Now let us see what exactly is going to happen. Right, so you all can see it is refreshing the screen and you're going to get to the application all over again. Yeah, and it flushed the screen, and you all can see as I scroll down, now you all can see because you ran the application all over again, meaning you recompiled it, you ran it from the beginning, you came to on create, you came to on start, you came to on resume, and your activity is running. Is that clear to you guys? Now these are the 3 function events which gets called, but you didn't see the other part of the program running at all for you. Right? Now this is what you saw in the PowerPoint, this is what you saw in developerandroid.com, and this is what we tested, and we all are able to see just the same stuff that is on create, on start, and on resume. Is that clear so far? Were you able to understand the flow of the activity? So I quickly want to see an act from all of you. So Neil says yes. How about others? All right, so this is, now I just want to show you something very curious. Now before that, let me take you back to the Edureka presentation. Now activity launched, and next is on created, then comes on start, then your on resume, now comes your running activity. Is that clear? Now guys, you know what? Now you may opt to click on some other application or a call may come in. Now what should happen to your application which is running now? I told you all in the first session that your application is going to go below the stack. Is that right? Now watch what happens. Now when some other application comes in, it can be a call or you would have clicked on some other application, another activity comes into the foreground, then your activity gets the control. In your activity application, that what you're getting, the on pause is getting called. That means when some other application is coming on top, the on pause of your activity is called. Now whenever it calls your on pause, it's your time to save all the temporary variables where you feel the data you're going to lose. That kind of data can be stored in your on pause, and I'm going to go deeper into it later. Now that is the temporary data will be stored in your on pause right in your activity. Then user navigates to the activity, meaning he goes to the other activity. Now the other activity will receive the resume, and then the other activity will start working for you. Then the control will go to on stop. Now that means it says that your activity is suspended, meaning your activity has lost the scope completely. Now some other activity has taken over. You know what? Now the other activity is running. Now when the other activity loses the focus, when he's done with the job, now your stop will go to on restart because you want to come up all over again, right? Then you're calling your on start, then you'll go to on resume. Now in on resume, now you can bring back all the variables that what you had in the temporary variable back to the application, and you can make your activity running. And this is how your activity can be brought in, right? Later on, now just in case, when all the applications are there on your phone, it may so happen that one of the application may be hogging the memory, or one of the application has not been used for a long time. Now, perhaps the higher priority, when it needs the memory, let us see what exactly is going to happen. Now here you can see the app process gets killed. Now this is there in the hands of Android. Now whenever it feels the application has not been run for a long time, and whenever it feels Android needs the memory, and it'll go kill the application and the process will be killed, meaning one of the idle application process will be killed. Now that is what will happen. Then the control will go back to the activity. Now you're back to the on create. Now you have one more possibility here. When you click the, let me go to my, oh, I cannot go from here. Yeah, when you click on at the bottom of your emulator, when you click on the back button, now the control will go to on destroy, and the activity gets destroyed completely. Now, if you want to start that activity, you have to start all over from the beginning again. Now, this is what is your on destroy. This comes into the picture when you click on the back button on the emulator, right? All right, guys, now this is the activity lifecycle. Now, let us quickly jump into the program and see how this works. So far, you would have understood the flow. Now, let me explain it through the code, how it really works. I'll be mapping everything through the code. After that, let me see how much that you guys are able to follow this. Right now here, after the destroy, you all can see your activity is shutting down. Now, let me quickly go to the code. Now you all know that you have come till on create, on start, and on resume. You know what? I'm just going to click on this rectangle and let me see if I have any applications. Now, unfortunately, I don't have any applications here. So what I have to do is I have to have some other application, or the best thing to do would be I'll change the orientation. When I change the orientation, also the same thing happens, right? I change the orientation. Now, when I change the orientation, it went into on pause mode, and it went into the on resume mode, it went into the on pause mode, and it went into the start, resume, pause, and stop, right? Now, let me change the orientation once again. All right, so you all can see, okay? Now, let me do something. Instead, I will compile one more application so that you will have it as a reference, so you all can know how exactly this emulator is working. Now, let me pick one more application. Okay, some application. so that I can show you how the stack is working and how the events are working. Now, yeah, it is loaded. It takes a while to load also. Now, anyway, I don't want to see the contents of this app, and let me just say okay. All right, so you have some application, so I don't care what it does and how it works and all that. Now I can, now I'll go to my Android monitor. Now here I'm just going to click on, see now you all can see the other application has come in. Now let me go give my tag. Now here, when I click on this rectangle, now you can see the stack of activities, right? Now this is the first activity, and on top of me the other activity came. Now I'm going to click on my first activity. Now when I click on the first activity again, it came to on start and it came to on resume. Is that clear to you guys? Now, when I override my application with another application, now again it regains the control from your on start and on resume. Now let me do this again. I'll go back by clicking on this rectangle. Now I'm going to click on location tracker. When location tracker came up, now you all can see my application came into on pause and on stop, right? It went into the pause mode and my application is stopped as of now. Now to gain the control back, now I'm going to click on this when the location tracker is done with the work. Now let me click on my first app. Now again, you all can see you're back in your on start and on resume. Is that clear to you guys? Can I quickly see an acknowledgement, or if you have any doubts, you can ask me to unmute and I can clarify this to you. Any questions so far? All right. So this is how you can see your application running, and this is what it means to be the life cycle of the activity. Now you're eager to know what exactly happens when I click on the back button. Let me click on the back button now. Now I just clicked on the back button. Now you know pretty well that the control has to come to on destroy. Is that right? Now watch this. The control came to on destroy. Now all this while you never saw control coming to on create. It is all on start, stop, resume, pause, stop, all that you're able to see. Now you have come to on destroy. That means your application is completely destroyed. Now if you bring in the application all over again, now you can see the applications here. Let me click on my first app. Now when you click on the my first app, you all can see on create, you all can see on start, and you all can see this on resume, right? Now because you started the application all over again, now it goes into start and it goes into resume. All right, so do you have any questions at this point? Great. So far we have learned how to create an application and how to create the life cycle of the activity, and we have learned how to create the button. We have seen about the life cycle of the activity. Now let me move on to my original app. Now so far this is what we have done. Now let me move back to my slides. Now this is where we all left, right? So now, if you want to watch, we came to on create, on start, on resume, activity is running. When some other activity is coming up, we went to the on pause and user navigation to the activity. We went to the on resume, the other activity came up, and our activity went to the on pause. Then it went to on stop, and then we went when the other guy is losing the control, when he's about to lose the control, we went to on restart, we went to on start, and again you went to resume and you started running your activity. Now, just in case, if there is any priority or if the Android needs a memory and apps with the higher priority need memory, at that point of time, Android will kill one of the existing apps from your best series of apps, and then it goes and calls the other activity of whatever has to gain control, because you're not able to execute one activity because you're running out of memory. So at that point of time, the Android kills the app which has not been run from a long time, and it loads your application and it starts your application. And after that, when you click on the back button, you guys are going to hit your on destroy. That means your application is completely killed. You saw that, and that means your activity is shut down. All right. Now that's about your activity lifecycle, and this is what you guys have learned so far. So it's time for us to sign out for the day. See you. Take care.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!